Hi everyone, Mr. Markwick here. Just a short video today as a bit of a recap into networks, or for those of you who haven't done the topic before, a bit of an introduction to networks. So what are networks? Networks are basically a map or a graph that is showing a relationship between things of interest and how they are connected. So this network here, you can see the things of interest we're talking about are the towns and an airport. The lines between those towns and the airport are the connections, and in this case those connections are actually the road. Okay, so the road between town A and C is shown with this line here, and in fact town A is connected directly to town C, town D, and the airport via a road. Okay, so that's what a network basically does. It shows the connections between things of interest. They don't always have to be physical connections. In this case, the physical connection is the road, but those lines could also show a relationship between two things of interest. So for example, who's friends with who, and such as teams that have played each other in a sporting tournament. Okay, so those lines are representing connections, whether they're physical or just relationships. So this topic that we're looking at, modeling with matrices, is actually going to be showing the connection between networks and matrices. So it's important that we understand some of the terminology around networks as well. So that's what we're going to talk about now. Those things of interest, those dots, the points, the towns in my previous example are what we call nodes when we're looking at a network, or vertices. Vertex is the singular. Okay, the lines that connect those nodes are called edges, but in a directed graph, they're called arcs. Now let's just go back to an undirected network first. So in an undirected network, basically between any two nodes, the line that connects them, there is flow in both directions, or you can move in either direction between those two nodes. Whereas in a directed network or a directed graph, you can see there's arrows here that actually show the direction of flow or travel. So in this case, you can only move from this node to this node in this direction. Okay, you can't travel back in the opposite direction because the arrow is not pointing in that direction. So in a network or directed graph, we have arcs, and they're represented by arrows on the lines. And in an undirected network, we have edges, and they will not have arrows. Some of the other terminology we're going to look at is the word route. So a route is basically a sequence of edges or arcs starting at one node and ending at another. So for example, a route could be A to E, to C, back to E, for example. But a path is a route which no vertex is visited more than once. So this is a path that's highlighted in red here, from A to B to E to D, because you don't go to the same node more than once. Okay, so that's pretty much it. That's what networks are. Hopefully you understand now what a node is, or a vertex, an edge and an arc, the difference between an undirected and a directed network, and the idea of a path and a route and a path. One thing I just want to point out quickly before I wrap up this video is that networks aren't always drawn the same, but you can see these two networks are actually topologically equivalent in terms of they're actually showing the exact same information. So for example, if I go to node A, from node A to node B, there are two edges. There is an edge from A to C, and there is an edge from A to D. Now, if I look at this one, it shows the exact same information. There are two edges from A to B, okay, one there, and one all the way around the outside. There's one edge from A to C, and there's one edge from A to D, and D doesn't have any more edges attached to it. So although you may draw a network differently, it may look different to the answers that you're looking at, it may well be equivalent if it's showing the same number of edges to and from a node. All right, so don't get too caught up on how your network looks. If you're drawing one, it doesn't look exactly like the person next to you or the back of the book. They can be equivalent even though they don't look the same. All right, so that's just a bit of a rundown, like I said, a bit of a review hopefully into networks. Hopefully it makes sense and hopefully it helps.